Hey everybody, how's it going? I am going to spend some time here today and show you guys how to rotate a door based off of a trigger. So with the rotation similar to that what we did with the planet in the last tutorial, but we're going to make it a little bit more involved because we are getting the collision of the character here, and we are going to have it trigger when it collides with a collision detection object inside of the door blueprint that we're going to be creating. Then that's going to be the trigger to open it, and then as soon as we leave that box, it triggers it to close. Right now for this project, I set up a default side scroller template, and I do have the starter content in here, but you really don't need it. What I did do was I created a door which is basically just a box. So if I import that FBX and I throw it into the scene, you can kind of see what it is there, and if I just play through it and I get the automatic collision there. So it is just a static object right now, but we will, in this lesson, set it up so that way we can get the animation to trigger with a collision object. Okay, so what I want to do now really quick, let me escape out of there. And I'm going to turn off my face so that way you guys could see the whole window. There we go. Okay, so in order to get this to work, we don't need this in the scene. What we need to do is create a blueprint. So we're going to create a blueprint class. It's going to be an actor. This is going to be our door BP. So it's our door blueprint. Double click on that, and we have it here in the scene. And if we drag in this door here, we have the door. Notice that I do have the pivot in the information on the corner here. There we go. Okay, so I have the pivot right there on the corner. And the way I did that is in Houdini. And you can do this in whatever software you're using, if you're using Blender or Maya or Cinema 4D, whatever it is. It doesn't really matter where the pivot of the object is when you're exporting your FBX. But if we go in and... oh, I didn't have it there. Well, I can create another one. Create a box. So if I have a object like this, right now the pivot will end up being right in the center. If I move it up like this, it's going to be on the bottom but in the center because it's based off of the origin. Then if I put this over this way, 0.5 units because it's a 1 by 1 by 1 cube right here, then the pivot's going to be right here in the corner. So wherever the pivot for your door is, you want to make sure that that section is on the origins or the 000 inside of your world in your 3D software. Okay, so that's how I get that there. So if you didn't do that, you'll have to re-export it as an FBX and have the pivot in the correct spot. Okay, I'm going to compile that now. And now that I have that compiled, what I want to do is add another object here. So where it says add component, we can search here. And I'm looking for the box collision. And there we go. So you can see by default it puts the pivot of wherever the object is right at the origin of the blueprint scene. The collision here is halfway, like right in the middle of the object, so that's why it turns out that way, whereas the box is kind of offset because the pivot is there. Now the shape of the box, we can adjust it here, and we can adjust the location here. So with this box, I know it's like 100 units wide because I created it. So if I wanted it to be right in the center, it'd be 50. And then going not forward and back, but up and down, this is 200 units, so you can see that's approximately 200 right here. If I could get it exactly on, that would be 200. So if I wanted it in the center, it's going to be 100 units. And then the height, like I said, is 200 units, so we can take the depth right here and put it to 100, and that's the size of the door. And then for the width here, 50, and that should get the door. We do want it a little bit thicker, so that way the door goes through that way. And what I found is that I actually want it to be quite a bit thicker, and then offset it a little bit in the Y. So let me select that again and go here to the Y. So that way, because it's going to open this way, and the character starts off on this side, I want him to easily be able to go through that way. And then on the other side where it's opening, I want it to trigger the open as it gets close, not right when it's on the door. So let's compile this, and let's look in the 3D viewport. We're going to have to throw that door in, and I can kind of rotate and make sure that it is lined up exactly, so that way the character can go in and out the door. Okay. So let's play this here. Let's see that right now nothing's happening. It does have that collision detection box, but we haven't told it to do anything yet. And you can see that the box is lined up the way we want it. So we have the thin side on this side where he starts off, and the bigger side that way. Let's jump back into the blueprint, and then we can look at the event graph. So we don't need anything to happen in the begin play, although we would like things to happen in the event actor overlap and the tick event. So the event actor overlap, that's going to trigger when it gets into this box here. And on the event tick, this is just happening every single frame. So it's kind of based off of your speed that your game is running at. So now I want to be able to get it to do something. I can have it open 90 degrees immediately, but the reason I'm going to be using the tick is that I would want to see it kind of open and close. So I'm going to need a variable, and let's say that variable can be triggered. So if we're in the trigger, go to variable, add variable here, triggered, and then I can throw that in here. Oops, I don't want to get the triggered yet, but I will use that later down here. I want to set triggered. So I can take this variable, drop it in here, set triggered. And I can connect the event overlap here. So when it is overlap, we want to set it to triggered. Another thing is, once he gets off of the triggered area, I do want to set it to be close or not triggered. So if we look at the events here, let's just search event and overlap, actor and overlap. So that one is the one that we're going to need. We can bring that here, and basically we're going to set this as well. So we can go here. This time it's going to be setting the triggered off. Then here we can check to see what the state of the triggered is. So we can set up a branch. So we can check to see if the branch is open. So if the trigger is triggered. Let's compile this, and by default it's set to false, which is good. That's what we want. So just like what we did last week, we're going to do inTrue and set a rotation value, and we'll start off with just having it rotate, so that way we can see the object itself rotating. So we're going to say so if it is triggered, we're going to set relative rotation of the let me look at the construction here. That's the static mesh. Oh, it lost its name. Variable name, let's say this is door. Not sure what happened. Okay, that's fixed. Let's compile. Let me make sure that it has the name out here. Yeah, not sure what happened there, but if you lose the name, there we have door. Okay. Now, let's go back to the event graph and right click here. We're going to set relative rotation for the door. So we have this door object. We want to make sure that if it is triggered, we are setting a new relative rotation. So what I'm going to do is create a door rotation speed. Variable door rotation speed, and that's going to be a float value, although yeah, we'll do a float value there. Okay, so we want to set this rotation. I'm going to right click and split the structure there, and I want to get the current rotation value. So we're going to say get relative transform for the door. Okay. And I think if we wanted to be a little bit cleaner, we can just connect that like that. Okay, and then I can split the structure pin, and then we're going to get the rotations here. There we go. Now let's look at the rotation of the door. So I'm going to switch over to rotation here, and as I rotate, you can see it says yaw there. That's the angle that we want to rotate in. So here we can see yaw. We're going to say float plus float. Float plus float. Then we have that there. And then we'll connect this into the yaw. And then compile this. I know that this isn't going to be exactly what we want, but let's test it out, because typically when you're running this, you're going to want to make sure that you're testing it out. And here you can see the problem. It is rotating in the wrong direction. So let's go escape. Let's fix that really quick. In order to fix that, we can just do -1. compile, and then let's play this here. And here we can see what it triggers. It goes through and opens. Okay, so that's working a little bit there, but obviously it's not doing everything the way we wanted it to. Let's just connect it directly to the event tick so that you can see kind of that the event tick is triggering this to happen right here. It's not the condition itself that makes it rotate, it's just using the event rotate to double check everything. So if we don't have that condition in, it has it go on forever. And let's look at the construction of the blueprint, because I think that's where our next issue is. So if we look at the viewport here, the box is inside of the door. So I'm going to take that, put it back into the main scene. Hopefully it'll let us do it. If not, there we go. I'll just put it in the default scene. So I just did Control X and then Control V to cut and paste it. Compile that there. And let's connect the event graph here again. And you can see now it will give us a little bit better result. So let's play this here. Now if I stay on the trigger, it's going to keep on going all the way around until it hits me. And then I'll stop over here. So if you wanted a kind of revolving door that could kind of work as you're walking through it, that would be pretty interesting. Okay, so let it escape to stop that. And go back into the blueprint. And so we got part of it working. We want it to go all the way up to 90 degrees and not go past it. And also we created this door rotation speed. Let's set this default value to -1. Okay, and then we can get that value. Let's drag that in here, get rotation speed, connect it there, and then now it should be whatever that value is. Compile, and it should work the same, so just double checking it. Works the same. Great. Okay. Now I want to be able to get this value here and test to see if it is over 90 degrees. So I am going to move this a little bit. Let's move this over. Okay, I'm going to create another branch here. And I'll connect this here and connect it there. So I want to take whatever this is, and I know it's going in the negative direction. So I'm going to say if it is float is less than or equal to b. And then I'm going to set this to -90. Actually, it should be, let's fix this really quick. It shouldn't be greater than. should be less than. Float is actually greater than or equal to -90. So now we are going through and we are checking to see if the value here is less or greater than or equal to -90. If it does, then it will keep on rotating it. So let's check that. Now if we go in here and we walk towards it, it should open it all the way up to 90. And right now when we go off, it will not trigger any other action, but it did stop for us right at the -90, which is great. Okay, so basically all of this in this section here is what we use to open the door. So I'm going to select all those nodes and then right click and then collapse to function. So we have a function here that is all of those nodes. If we wanted to, we can go in and rename this. This is our open door function. Let's compile this and play. You see that it does open the door for us. Okay. Then now we need to be able to set it to close the door. So what I'm going to do is copy this. Actually duplicate it. If we right click, we can go to duplicate. This is just going to be close door. Okay, so there's going to be some adjustments that we're going to need to do here. So when we close the door, we are checking to make sure that, well, we'll check to see in the event right here, it'll be false. So if this is false, then we'll go to the close door action. Then close door, here on this condition, let's delete that, and then we are going to check to see if this value is less than or equal to, yep, so float is less than or equal to 0. And if it is, it's going to do this. The only other thing is that we need to do a float times float, because we want to use this speed, but we want it to be in the negative direction of whatever it is. So we're basically going to tell it to use the rotation speed, but in the opposite direction of what it is. And then all of this should be the same. Okay, compile, and then let's go to the event graph, and let's drag in the closed door, and throw this in here. Compile this, and let's check out to see how it works. We go here, it's triggering it open, and as soon as we get off, it goes through and closes. If we go this way, it will open. So it is working as a opening and closing door for us. Right now, obviously, there's no wall, so we can go pretty easily right over it, but imagine if there's a wall around it, and then we can have a opening and closing door. Okay, so that is it for this tutorial. I hope you guys found it useful. We'll see you guys in the next video.